Hello everyone, in this video we're going to learn how to prove the direct comparison test for convergence. Now theorem 10.6a, the direct comparison test, let the series an greater than 0 less than equal to series bn for all n. Number 1. If the series bn converges, then the series an converges. Number 2. If the series an diverges, then the series bn diverges. Alright. Now we're gonna prove number 1 first. Right. So let's start off with the partial sums of each series. Now since a sub n and b sub n greater than or equal to 0, right? So we have s sub n always less than s sub n plus a sub n plus 1, right? Now s sub n equal this guy right here, right? So I just replace s sub n with this guy, right? So it's gonna be the series ai when I goes from 1 to n plus a sub n plus 1, right? And this guy actually the series ai when I goes from 1 to n plus 1, right? I combine this guy and this guy, right? And this guy actually s sub n plus 1, right? Now similarly we have now on the top right here we can conclude that s sub n less than or equal to s sub n plus 1. The bottom y sub n less than or equal to y sub n plus 1, right? From these two guys we can conclude that Sn and Yn are increasing sequences, right? Now since a sub n less than or equal to b sub n for all n's, right? Then we can conclude that s sub n less than or equal to y sub n, right? Now number 1, suppose the series b sub n when n goes from 1 to infinity converges. And we know that b sub n always positive, right? So we have y sub n equals the partial sum bi when I goes from 1 to n always less than or equal to the series bi when I goes from 1 to infinity, right? But s sub n less than or equal to y sub n, right? So from these two guys right here, we can conclude that s sub n less than or equal to the series b sub I when I goes from 1 to infinity by transitive property, right? But this guy right here converges, right? Then s sub n converges, right? But s sub n is the partial sum, right? So when the partial sum converges, the series must be convergent, right? Now let's prove number 2. If series a sub n diverges, then the series b sub n diverges. Now suppose the series a sub n diverges. Since a sub n positive, right? The limit of s sub n when n approaches infinity is infinity, right? Also we know that s sub n always less than or equal to y sub n we proved above, right? So we can conclude that limit of y sub n when n approaches infinity is infinity, right? So it tells us that the series b sub n when n goes from 1 to infinity diverges, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
Tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.